there is a tunnel. And machinery inside that tunnel sends beams of energy in a vast circle.
And how the particle accelerator altered the weight of one electron and therefore destroyed our universe and shifted us into the universe that's directly next to it, and therefore things are different in this universe.
Inside the tunnel, powerful machinery emits beams of energy that travel in a vast circular path, exploring the fascinating phenomenon of how the particle accelerator impacted the weight of an electron, leading to a significant transformation in our universe and creating a parallel universe with distinct characteristics. In September 2008, the highly anticipated Large Hadron Collider LHC, the world's most advanced high-energy particle collider, finally became operational. The construction of this project, undertaken by the European Organization for Nuclear Research, was a meticulous and laborious process. Throughout its existence, the LHC has greatly expanded our knowledge of the universe. Nevertheless, physicists are currently perplexed by a recent development. After cranking up the power of the LHC to its highest level, the researchers at CERN stumbled upon a surprising and puzzling outcome. Since then, the scientific community has been abuzz with theories trying to make sense of this unusual occurrence. What caused such a devastating event, and how does it impact us now and in the future of scientific endeavors? Stay tuned as we uncover a multitude of intriguing secrets. Imagine a colossal machine that stretches across 2 countries and delves deep beneath the Earth's surface. It's truly mind-boggling. Step into the extraordinary realm of the Large Hadron Collider LHC, a remarkable feat of human ingenuity crafted by CERN. This machine is not your average piece of equipment. It holds the title of being the largest and most powerful particle collider in the world. Its story is just as captivating as its purpose. CERN, the European Organization for Nuclear Research, is a shining example of global cooperation and a hub for scientific exploration. Its roots can be traced back to the aftermath of World War II, when Europe was in the process of recovering from the destructive conflict. Scientists and policymakers increasingly agreed that working together was crucial for revitalizing the continent's scientific capabilities. In 1950, the esteemed physicist Louis de Broglie put forth the idea of establishing a collaborative European laboratory with the aim of revitalizing scientific innovation and fostering peaceful cooperation in a short amount of time. In 1952, 11 countries joined forces to sign the CERN Convention, which laid the foundation for the establishment of the organization. In 1957, CERN became operational on the border between Switzerland and France. CERN's main focus was on studying atomic nuclei and their constituents. In order to accomplish this, particle accelerators were necessary. These massive machines accelerate particles to almost the speed of light, colliding them to uncover profound revelations about the fundamental components of the universe. In the 1980s, the concept of the Large Hadron Collider LHC started to develop. As scientists became more ambitious, they realized the need for a more powerful machine to delve deeper into the mysteries of matter. The LHC was designed to be the epitome of scientific innovation, with its impressive 27-kilometer ring of superconducting magnets and detectors. The construction of the LHC commenced in 1998 and was truly a remarkable feat of engineering. Located 100 meters below the surface, this massive loop was the result of a global effort involving countless scientists and engineers. After 10 long years of hard work, the LHC was finally prepared to embark on its thrilling journey of particle smashing in 2008. But why such a profound level? Well, besides protecting the collider from the outside world, the depth ingeniously navigates around the difficult terrain of the Jura Mountains. By doing this, there was no need to excavate a large vertical access, resulting in substantial cost savings. Why would anyone want to invest in costly land on the surface when there is plenty of space available underground thanks to the LHC? However, the purpose of this extensive underground operation remains unclear. In 2010, it accomplished its first particle collision at an astonishing energy level of 3.5 tera-electron volts per beam. Just to give you an idea, it was nearly 4 times higher than the previous world record, and that was only the start. Following some enhancements, it now showcases a remarkably enhanced 6.5 tera-electron volts. Picture two beams of particles hurtling towards each other at incredible speeds, only to collide with a tremendous force. That's the LHC in action. There are 4 distinct points where these high-speed particles come together and collide. 7 detectors eagerly await around these points. Every observation is carefully crafted to uncover and decipher the multitude of phenomena that arise from these collisions. Typically, the LHC collides proton beams, but once a year, it shifts its attention to heavy ions, such as lead, for a whole month. It's similar to the machine's exclusive yearly gathering. Now you may be wondering, what's the point of going through all this effort? Our fascination with the universe holds the key. Physicists are utilizing the LHC to examine and validate some of the most perplexing theories in the realm of particle physics. They have a particular interest in studying the mysterious Higgs boson and exploring the potential existence of a wide range of particles from supersymmetric theories, including hadrons. These particles are incredibly small, composed of even smaller components known as quarks. Imagine them as the fundamental components of protons and neutrons. The LHC is named after these particles because it collides them together, resulting in the production of byproducts. Several of these byproducts have a very short lifespan and cannot be examined through any other means. Whenever there's a collision in this expansive underground ring, it feels like a miniature explosion of epic proportions. Scientists are able to gain a fascinating insight into the fundamental nature of our universe. It's all about the building blocks and the forces that bring everything together. Exploring the enigmatic realm of the Large Hadron Collider, this underground tunnel was built between 1983 and 1988. It is an impressive structure measuring 3.8 meters wide and fortified with concrete for maximum security. High above the ground, there's a towering structure brimming with vital equipment. Picture a room filled with intricate control electronics, compressors, ventilation gear, and cooling systems. Now brace yourself for something truly mind-blowing. Every year, the LHC generates an astounding amount of data, reaching approximately 15 petabytes. Dealing with such a vast amount of information can be quite a challenge. Fortunately, an impressive international collaboration came together to create a specialized computing grid for the LHC. This network is truly impressive in its own right. The primary objective of the LHC is to unveil the enigmatic properties of a particle known as the Higgs boson. This particle had an ethereal presence. Scientists had predicted it, but it had never been witnessed before. The high mass of the object made it incredibly difficult to capture on video. The LHC, with its impressive capabilities, aimed to generate numerous Higgs bosons every minute. It's akin to luring in an elusive being that countless people believed in, yet had never been successfully apprehended. Furthermore, the LHC didn't stop there. In addition to its pursuit of the Higgs boson, it ventured into unexplored realms of physics. It explored supersymmetric particles and other mysterious phenomena in the universe. Nevertheless, there were some challenges along the way. Shortly after its launch in 2008, the LHC encountered a major obstacle. The collider experienced significant damage due to a malfunctioning magnet, resulting in a delay of over a year for its tests. However, after it began operating in 2009 and continued until 2013, the LHC produced some amazing findings, one of them being the identification of the long elusive Higgs boson. Following its initial successful operation, the LHC entered a period of hibernation to undergo necessary upgrades. It emerged from this phase in 2015, fully prepared for a new series of exciting endeavors. The second run lasted from 2015 to 2018, and then there was a break until it restarted in April 2022 with an increased beam energy of 6.8 TeV. This machine's upcoming video promises to captivate us until 2026. Something extraordinary occurred on July 7th during its third run. The mysterious crack. Picture Earth's magnetic field as a shield safeguarding our planet. On that day, an enigmatic fissure materialized within this sphere. This was not a mere momentary malfunction either. It remained open for an impressive 14 hours. Imagine a window unexpectedly left ajar during a turbulent evening, allowing the cold gusts to sweep inside. A crack in the system resulted in a surge of solar winds from the sun, causing widespread geomagnetic storms. What is the outcome? Witness breathtaking spectacles of auroras in the sky. If you're a fan of Stranger Things, you may remember Vecna, the terrifying antagonist. Some fans playfully speculated if Vecna had appeared from this exact crack. Although it's just a playful theory, there's no denying the mesmerizing beauty of the auroras. But what caused the formation of this crack? The culprit in question is a co-rotating interaction region, CIR, originating from the Sun. CIRS are expansive plasma structures formed through the interaction of varying solar wind speeds. Picture two rivers coming together, one flowing leisurely and the other rushing, creating a powerful cascade. These CIRs, along with other phenomena like coronal mass ejections, are emitted by the Sun and directed towards Earth. We are treated to a dazzling display when they make contact. On the early morning of July 7th, a mesmerizing collision of charged particles resulted in a captivating geomagnetic storm. The National Oceanic and Atmospheric Administration, NOAA, also mentioned that this storm was intensified by a preceding coronal mass ejection. Is there cause for concern regarding these cracks? It is worth noting that experts provide a reassuring perspective. Actually, cracks in Earth's magnetic field are quite common and can compromise its protective shield. Typically, these situations resolve quickly. However, recent events have demonstrated that they can persist for hours. Picture yourself in a cozy home, braving a storm, with a window that has a tendency to get jammed open. Even though the majority of the storm is diverted, there is a possibility that the couch could be damaged by water. In a similar vein, although our magnetic shield is effective at deflecting the majority of space storms, a small amount of energy manages to slip through. Occasionally, these phenomena can wreak havoc on our satellites, radios, and power systems. In 2003, Harold Freya made a comparison between our magnetic shield and a drafty house. Occasionally, a few bursts of energy manage to slip through the barriers, resulting in a mesmerizing display in the sky or causing disruptions to our technology. Fortunately, there were no radio blackouts or power outages that occurred as a result. Instead, this cosmic event brought a breathtaking surprise for the residents of Canada and the US, filling the sky with mesmerizing northern lights. However, there is additional information to consider. Scientists have revealed a fascinating discovery. The Sun is really starting to come alive. Surprisingly, it's displaying a higher level of activity than they expected at this point in its cycle. What implications does that have for us? It's now much easier to witness the breathtaking beauty of an aurora. In the upcoming years, anticipate a more frequent display of vibrant colors in the sky. Exploring the inner workings of the LHC and discussing the awe-inspiring scientific breakthroughs brought about by the Large Hadron Collider LHC. Consider the LHC as a colossal microscope, enabling scientists to observe the minuscule particles in our universe. In July 2017, it made some remarkable discoveries, such as uncovering the properties of the Higgs boson. In 2021, the LHC made a significant discovery by identifying 59 new hadrons. In July 2022, an intriguing discovery unfolded as scientists observed a novel particle known as the pentaquark. This particle is composed of distinct combinations of quarks, adding to our understanding of the intricate world of particle physics. Nevertheless, even the most exceptional devices, such as our treasured LHC, encounter obstacles. Over time, their ability to generate innovative outcomes diminishes. However, scientists possess a clever technique. They make improvements. The LHC is currently undergoing an upgrade called the High Luminosity Large Hadron Collider, started in June 2018. This project aims to enhance the capabilities of the LHC, enabling it to more effectively detect and analyze rare cosmic phenomena. What makes the LHC famous? During its initial run, it made the groundbreaking discovery of the Higgs boson. The second run of the LHC provided even greater understanding of this particle. Now, with its third run planned to conclude in 2025, scientists at CERN are optimistic about the possibility of obtaining twice the amount of data and potentially uncovering twice the number of discoveries. The Large Hadron Collider LHC at CERN is preparing for an exciting adventure. Imagine this. In 2029, this massive machine will be colliding particles at rates that are 10 times more intense than ever before after extensive preparation. And the excitement continues. During this phase, which is projected to last until 2042, there will be a significant increase in the size of the data sets compared to the end of its third run. Now, if you're curious about the significance, let's explore the exciting realm of proton collisions. Imagine protons as vibrant bags filled with a variety of jelly beans. In these bags, you'll find smaller particles known as quarks, held together by even tinier particles called gluons. It's as if nature's smallest elements are engaged in a graceful choreography. Imagine the collision of two bags filled with colorful jelly beans. Often, the jelly beans or particles disperse, coming together again in recognizable formations. But occasionally, something enchanting occurs. Two quarks or gluons collide directly. This collision condenses all their energy into an incredibly tiny point before unleashing it with a powerful explosion. In these exceptional moments of heightened energy, physicists have the opportunity to uncover the profound mysteries of nature. However, there is a fascinating challenge involved. Within the LHC, bunches of protons collide at an astonishing rate of 40 million times per second. Just picture this. You're attempting to capture a one-of-a-kind moment from an endless fireworks show, where every explosion yields a photo that's 20 times bigger than what you'd take on your smartphone. Collecting all this data would rapidly consume a database's storage capacity, accumulating a staggering amount of information every passing second. Wow, there is a significant amount of data. In the vast sea of events occurring every second, the majority are quite ordinary. Hidden amidst this deluge of data, there lies a singular and remarkable Higgs boson event. So, how do scientists manage the overwhelming amount of data they have to deal with? Introducing the Trigger, a cutting-edge computer system that operates with the precision of a skilled photographer, carefully curating a selection of the most captivating collisions every second. These moments hold great significance for scientists, as they eagerly seek to uncover the mysteries of the universe. The Large Hadron Collider LHC is an immense scientific tool that allows us to delve into the fundamental components of our universe. Picture a colossal contraption dedicated to unraveling the mysteries of creation. Its primary objective is to discover previously undiscovered minuscule particles that may reveal hidden cosmic mysteries. Exploring the mysteries of dark matter with a new LHC. Now, it's worth noting that some of these particles have a significant mass. Imagine them as the ultimate powerhouses of the universe, breaking down into smaller particles and unleashing incredible amounts of energy. However, many scientists are skeptical about the possibility of discovering these large entities during the LHC's third run, also known as Run 3. Instead, we may come across glimpses or hints, similar to embarking on a treasure hunt and stumbling upon a map instead of the actual treasure. These clues could potentially be the sneak peeks for more exciting revelations in upcoming episodes. Here's an interesting variation: exploring the mysterious realm of dark matter. Chances are, you're already familiar with the mysterious substance that lurks in our universe, unseen, yet significant. There could be some new particles that are potentially connected to this mysterious dark matter, but they are incredibly elusive and rarely reveal themselves directly. It's as if attempting to perceive the wind. Although it remains invisible, its presence is evident through the subtle movement of leaves. In the LHC, we search for other particles that exhibit peculiar movement, suggesting the existence of these imperceptible entities. Nevertheless, there is a hurdle to overcome. Oftentimes, these signs are incredibly faint, causing our detectors to overlook them. It's as if attempting to catch a faint murmur amidst the deafening roar of a concert. However, with some enhancements in Run 3, we are fine-tuning our ears, or rather our detectors, to better detect these subtle indications. And that's not all. Exciting developments are in progress for an even more impressive boulder machine known as the Future Circular Collider. Imagine it as a larger counterpart to the LHC. This enormous particle smasher could have a price tag ranging from 9 to 21 billion euros. However, there are some who are not in favor of this idea. There are those who argue that considering the high cost, it is worth exploring other ambitious scientific endeavors. How about a giant radio telescope on the hidden side of the moon, or perhaps a device in space that can detect cosmic ripples known as gravitational waves? Sabine Hassenfelder, a renowned physicist, suggests that this new colossal machine may not reveal the desired secrets. It's similar to investing in a high-powered telescope that may not reveal any undiscovered stars. However, there are exciting developments on the horizon, including the upcoming runs 3 and 4 of the LHC. It feels as though we're immersed in an enthralling cosmic investigation, gradually unraveling clues that lead to even more intriguing discoveries at every turn. Imagine them as episodes of an exciting series that we're about to binge-watch. One interesting surprise occurred when Earth's magnetic field remained open for a longer duration than anticipated. It's as if you stumble upon a secret passage within your own home that you were completely unaware of. What other discoveries await us? Max Lauchlin's thought-provoking theory. According to brilliant minds like Max Laughlin, though, we might be facing some challenges. According to Max Lauchlin's theory, experiments conducted at the European Organization for Nuclear Research, CERN, have resulted in a shift for humanity into an alternate universe, giving rise to the phenomenon commonly referred to as the Mandela effect. Laughlin suggests that the energetic particle collisions conducted at CERN might have unintentionally resulted in a disturbance in the fabric of space-time, leading to a slight shift in our universe. The Mandela effect, which is based on the misconception that Nelson Mandela passed away in prison in the 1980s instead of 2013, is a fascinating phenomenon where a significant number of individuals recall events or details in a manner that differs from the actual occurrence. Supporters of the theory argue that these collective misrememberings are not simply memory mistakes, but rather indications of our shift into a different reality. Laughlin's theory, although intriguing, has been met with skepticism from many in the scientific community as it remains speculative. The experiments at CERN are undeniably at the forefront of scientific exploration, pushing the limits of our knowledge about the universe. However, there is currently no solid evidence supporting the notion that these experiments can transport us into an alternate reality. Safety protocols at CERN have been a topic of concern for many, as various theories have sparked worry among the general public. CERN prioritizes safety in all of its operations. Our top priority is to ensure that strict protocols are implemented to minimize radiation exposure. Personnel operating particle accelerators and detectors are provided with dosimeters, and areas with radiation hazards are closely monitored and regulated. Strong engineering designs and protective materials are utilized to confine radiation. Ensuring chemical safety is of utmost importance, requiring careful handling and proper disposal of hazardous substances. Ensuring electrical safety and fire prevention is a top priority at the facility. Regular checks are conducted to make sure that all electrical systems meet international standards. Additionally, CERN places a strong emphasis on ensuring the safety of its workforce. Our comprehensive training programs and safety drills ensure that personnel are well prepared to handle any emergency situation, whether it's a fire, chemical spill, or radiation leak. In addition, there is a comprehensive medical service available on site to promptly address any health-related concerns. Environmental precautions are just as important. CERN takes great care to minimize its impact on the environment, responsibly manages waste, and diligently monitors air and water quality to ensure no contamination occurs. CERN prioritizes safety and takes measures to minimize risks, including implementing public access control. It prioritizes maintaining open lines of communication with local authorities and actively engages with the community to address any concerns that may arise. We appreciate your presence. Don't miss out on the upcoming video playing on your screen. Absolutely incredible.